Hey Michelle, how are you doing?
Yeah, hi. Finally got our bathroom fixed. Yay.
Yay!
Only 3 months later.
That's good. At least now you can use the bathroom for the holidays.
Yeah. Yes.
That's good. Well, one good thing, right?
Yes. Yeah.
Yeah. Okay, cool. Kevin's here, Ghislaine's here. Okay, so today is our last official session before the final exam. Sorry, I scramble every Monday to get stuff published and things like that. So if you want to check out Canvas, final review is up. I'll go over every question. And then if you have any questions, let me know. So week 16 is going to be the final exam. It's multiple choice, 50 questions, 4 points each. Okay. All right. So let's share screen real quick. So final review going to be unit 2 through 13. Like I said, the final exam is going to be multiple choice. You will have some snippet of code in various part of the final, but it's pretty straightforward. Let me fix this real quick. I forgot to set the point for this. I just saw it right now. And you can't submit. Okay, it should be fixed now. Okay. So if you finish it with it today, you can turn it in, but it's not due until the 5th. That gives you some time to look it over if you want to redo some of the questions. Like I said, I'm going to go over the final exam or the final review questions now. So final exam is going to be 50 questions, multiple choice, 4 points each. That will be 200 points for your final exam. So in the first question, it asks you to fill in the blank. It asks you, the blank is the technique to pinpoint most resource extensive spot in the application. And we start out with unit 2 or chapter 1 with profiling. And so profiling is a technique that we can identify what part of our program is going to be the most intensive. And then we went into profiler and C profiler and so on. So the answer for number 1 is profiling. And you will find this in the last module of your Canvas. For number 2, it asks you what type of program is used to run an application and monitor how long each function would take. And that will be a profiler. So simply, it is a program that we would be able to use to monitor our functions. And that was also part of chapter 1. Number 3, what type of Python profilers use the C extension and it is suitable for profiling long-running programs? And we would have to use C profiler. Remember that when we use C profiler, we want to use either a Linux virtual machine, or if you use Visual Studio, you need to make sure that you add in the Python packages and be able to run the C extension. So C profile is the answer for number 3. Any questions so far? The reason why we don't do unit 1 is unit 1 was mostly review of the prior classes. Okay. For number 4, when designing an application, which of the following option is not an approach in optimizing code? And so we learned that in designing an application, we want to first make it run. Then second, we want to make it right. So make sure that your your program produce correct output. And then third, we want to make it fast. So D is not an approach in optimizing code, even though it does make sense that we learn about parallelism or parallel programming. So in design, we want to make it run, make it right, and make it fast. So make sure you know all three. For number 5, what type of profiling tool consists of a GUI that is useful to analyze and profile output from C profile using Linux KDE? And this is when we use Kcache grind. That's when we have to install really resource extensive desktop on the Ubuntu. So Kcache grind. It gives you the graphical user interface when you're using C profile. So in your code, you still have to use C profile, but on top of that, we would use Kcache grind. For number 6, to use, sorry, I had to type it fast, to use line profiler module with the functions that need optimizing in Python code, what would be used to monitor the function in the program? Not a good phrasing question there, but we would use a decorator and we would use @profile. This allows us to monitor the function in the program, and we simply place that right above the function. And so when we define C function using a lot of these tools, remember that we have to do CDEF instead of just DEF when we define the function. So we would use the decorator for that. That would be the answer for number 6, @profile. And that is when you use the line profiler. So it would check line by line. Any questions with these? We saw them on prior assignment and tests already. So this test should be pretty easy. Okay, for number 7, in Python, which module is used to inspect bytecode instructions in the application? And we would use DIS module. DIS module is used to inspect bytecode instructions. So the majority part of this class, we implemented Python libraries. Okay, and then we also learned how to be able to use those libraries to create multi-processing program, parallel program, or concurrent program. And we can improve the performance using different approaches. Okay, for question 8, true or false? Optimized time is used to describe the amount of time to run an algorithm, and that's false. In all programs, not just Python program, time complexity is used to describe the amount of time to run an algorithm. O of n, we would use the big O notation. And depending on the algorithm, right, we would then be able to specify what type or the time complexity of our program. So if you simply implement a for loop for iteration, that will be O of n. And in different type of program like binary search or other type of program where we would implement more complex algorithm, we would have different time complexity there. So in a for loop, we have O of n, where n is going to be the number of input. So if you have an array of 100 elements, right, n will be 100. So false for number 8. Nine, you have to take a look at the program and we would determine the time complexity of the program. Let me scoot it down a little bit. So here we're given number 6538424 or 6, yeah, and 411. And we are doing a running sum or finding the total as we loop. And we would print out the sum. So as you can see, we only implement a for loop here. So our time complexity denoted with the big O notation would be O of n. That will represent the time, where n is the number of input or elements in the list. And in this case, we have 9 elements. So if we're looking at for one element, that would just be like if we need to access the 6 here, for the first element, that will be O of 1. Okay. Any questions? So for question 10, it tells you that you're given a program that uses bisect module. And we want to describe the purpose of line 6, in which we declare an object called POS. And that object is going to store bisect.bisect method. So bisect method test score 96. So that object is going to store the insertion of 96 into the sorted list as it sort right before it here in line 3. So test score became sorted, and then it's going to insert the value that you specify in your argument, 96. And using bisect, it's going to return the position of the inserted element, which is 4. So when we run the sort, it's going to place 72 in the front, then 85, or I'm sorry, 81, and then 85, and then 90, and then it's going to insert 96, and then 98. So 0, 1, 2, 3, 4, and then 5. So the position we will get is going to be 4 when it prints. And in the units, we talked about bisect module. So that's when we start working with how we want to really use the data in the container. Okay, any question? All right, pretty easy. For number 11, you're given a program and we want to explain the program procedure and output top to bottom. So at the top, you should see an import statement. We are going to import deck from the collections module. Then we have a DQ object, which is a deck object, and it's going to contain the string ABC. Right after that, we are going to extend the string. And remember, string is just an array or a list of characters. So when we extend that, we would have DEHIJ added to ABC. And then on line 7, we are going to rotate, but in this time, we're going to do rotate -1. So what's going to happen is it's going to take, after it add the items to the deck where it extended, it's going to rotate left where it's going to take the A and put it at the end of the list. So when it prints, it's going to print DQ as a deck because that's an object of a deck here. And it's going to show B, C, D, E, H, I, J, and then A. So the first element is rotated and it brings it back to the end. So add it to the end of the list there. And so when we say rotate -1 like this, it's going to scoot everything to the left and then push A to the back. So to further explore this, we need to take a look at deck and how to create a deck as we revisit it down the line, right? So we learned this in 30A as well. Any question with 11? Okay. Let me move this up a little. Okay, for 12, fill in the blank. A blank is a data structure that associates a set of key value pairs. It is used to assign a specific index to each key so that its associated value can be stored in an array. And this is called a hash map. So when we learn about data structure, we talk about hash mapping. And this is used for us to associate data in a dictionary structure. And dictionary is simply a multi-dimensional array. Okay, 13, you given the below program, we want to describe the program procedure and output. So in this one, we are using default predict from collection module. So the first statement, we're going to import default dict subclass from the collection module. Then the second line, we define hats list. Then on the fourth line, we define an object called D, and it's going to store what's called the default factory using default dict subclass or child class from the collection. So default dict class. Then after that, we simply want to use the for loop. And before we print, we want to append, right? Because it's two values that we're looking at. One is a string and one is going to be the integer. So we have to use a nested for loop. So in Python, we simply write it in one line, but it's actually for I, right, in hats, and for J in hats. So we're going to be able to access the value in the tuples inside the list. And so we would use a for loop to display the sorted default factory content. And so here, that's going to give us black is going to show first. And that is 60. So it's going to take black and put that first because it's alphabetizing it for sort. Blue 50, brown 35, green 15, red 20, and white 40. So this is a quick way where we can sort, right, using iteration. Python is beautiful in that it's just so much simpler compared to C++ or Java. So here, what you establish is what's called the default factory. And we implemented default dict. Question? Okay, for 14, you're given a program and you want to describe the program procedure and output. So we would start with defining a list called foods. And with the food, we have various strings: large pizza, medium lasagna, small soup, small salad, large spaghetti, and large steak. And we want to, in this program, basically it's going to search. So in our foods list, it contains strings. Then we're going to define object seek to search the string large. So here, what we have is we would have order for order in foods, right? If large in order. So we nest the if into the for loop. And then we want to print out what's contained in seek. Then we define the index dictionary. And here we have a nested for loop. So we have for I order in enumerate foods. So we're going to loop through the list. And as we loop, we're going to split the string. So the two words is going to get separated. And we want to index the large string. So results is going to store the index of the items that contain the search key. such as large pizza or large spaghetti, right? And this is a technique where we would use what's called the inverted index. So we use invert index to search for large and store that in the result word list. So in result words, we also implemented another for loop. And so we want to print out which element contains our search key, which is large. And then the result words would be the key itself with the item. So you would have the index found 045. And then for the inverted index, that will be for the result words, we would have large pizza, large spaghetti, and large steak. So you can do it with the iteration, okay, like this, or you can do it with inverted index. Either way, you're still going to get your outcome for that keyword large. Okay. And this might be helpful for your project. So as we have the outcome from the program, the last two parts is just display the result containing the index, display the result words that contain the strings including large. So as you create data structure, right, we want to be able to use different techniques in order to seek your data, to sort your data, to add data, to move data around. And so these are some of the things we've learned earlier on in the semester. Any question with 14? Okay. For 15, given the below Python code snippet, write the statement that converts data type to float 32. So we have an import statement, and here we use NumPy. And we have an array called myArray. And we want to specify that this is a NumPy array. So they are all integers, and we want to make this to floats. So there are two ways to do this. You can do AS type, and you specify the type in quotation marks. So you can say myArray.as type. So you can use AS type method and then put in the data type inside quotation mark as your argument. Or you can reassign, right? When you define the array, you can simply use D type and assign D type as float 32, and it would achieve the same thing. So this is how we can convert data type without having to parse them individually in an array. And so using NumPy, you can use AS type method or D type. Because the longer way would be iterate through it and then parse each of the value in that. It would take more processes for our program. So we want to simplify that. So when we run this, right? So here I have the D type and the float. This is very close to your assignment that we've done. And so instead of just the integer now, it puts the decimal points as it converts that to the floating points. Okay. Then for 16, you're given a Python snippet. We would write the statements to slice the array into 3 elements using an index value and display its content. So here we have the array and it contains 6 elements and we want to cut it in half. So we would define S array and we would use the original array and we would use index 0 to 3. So it's going to cut it right here. Okay. And then we want to print to show. Any question? Okay. So for 17, it asks you to fill in the blank. The blank is an object that maintains a reference of a specific area. And we talked about memory view when we talked about Python or CPython. How in Python we were able to use pointers and reference variable because it's C-based. And when we use compiler, it's going to be much faster than when we use the interpreter. So memory view is an object that maintains a reference of a specific memory area. For 18, which the following option is not a technique to add compiler directives to Python code. The option B is not a technique because we can use a decorator or context manager to add compiler directives. And so we play with using Jupyter Notebook, and then it works better if you implement that in Linux versus Jupyter, because Jupyter sometimes is a little sketchy with Python or Python, CPython. The second technique we can use is we can comment the beginning of the file. And we would use the double percentage symbol, especially when you use Jupyter Notebook or Sage. Or we can use the Python command line options. So those are the 3 ways to be able to add compiler directives. So B is not a technique. Any question? Okay, for 19, given the below Python script, describe how pointer is used in the program. And this is an example from our assignment. So here we're using Python, right? And we define a variable 1, which has data type integer. And then we define it as a pointer by using cdef. And then we dereference the pointer. Then we would assign the value to var variable 1 or var1. And so using Jupyter, we have to be able to display. So we would use printf, that would work. That's a function for print in C. And then we simply print. And here is where we pass the pointer in the print method. So pointer is used to display the value of var1, which is 100. For number 20, it asks you which Python module is used to translate Python function to optimize machine code at runtime using industry standard low-level virtual machine LLVM compiler library. And that will be your number. And when we cover number, we talked about using just in time. So for 21, it asks you what type of decorator and functions that implement different input types to be able to select specialization at compile time without jeopardizing the runtime speed of JIT or just in time. So we would use the generated JIT or generated just in time decorator. So for 22, given the below code, we would use inspect type method to display the function about the type while the program is being compiled. So we simply, for this program, we use NumPy, we generate an array that contains random numbers. We would print the array, and we have a function called double. We would take each element in that random array, and we would multiply it by 2. So we would double it, and then we would print out each of the element. So to be able to inspect the data type, then we simply use a just-in-time decorator. So at JIT, and then we would use the inspect type method, and we simply use that as a method for double, which is the function that we define there. So we call that function pretty much. And then we can simply print after that, right? But I didn't add the print line. So we simply just add the decorator above the function. And then we use the inspect type method at the end. So when you run this, it's going to give you information about the type as it goes, as it compiles the program. Doesn't work too well with the interpreter, but you do get some output. You can run it in Linux, or if you use Visual Studio, you can do that. This also came from one of the old assignments that we've done. Any question? Okay, almost halfway there. Okay, for 23, what type of parallel programming allows a unit of work to run separately from primary application thread and notifies the main thread about the completion or failure of the worker thread? And this is part of asynchronous programming. This is where we use async IO, and we start diving into parallel programming. For 24, what type of subroutines are used to cooperative multitasking, where a process voluntarily controls periodically or when idle to enable multiple applications to be run simultaneously? And that will be your coroutines. And so coroutines are simply defined as a generalized subroutine. For 25 in concurrency programming, what feature implements the wait to allow the rest of the program to continue execution without waiting for the beginning execution? And remember how we were looking at the diagram where we can have the feature where it would execute, right? Task 2, task 3, task 4, without waiting for task 1. And this is a feature called callback. For 26, in concurrent programming, in a concurrent program, what is used to pull status of the event while allowing other tasks to be executed? We would use event loop, and that can be implemented as a while loop with a callback. And we saw some example in the text, and also we work on this with the lab. And for 27, what type of library can be used to implement concurrency in Python program? And that's pretty generalized, right? Because concurrent programming can be vast. And in this particular course, right, we focus on the section for concurrency. We use async IO. And then we touch on like generating file, like text file 1, 2, 3, 4, 5 in our exercises. In a concurrent Python program, what method is used to execute the coroutine? And using async IO, I should say. And we would use the async IO .run or the run method of async IO. To execute. So run method from async IO is the answer for 28. For 29, what type of library is used for composing asynchronous and event-based programs using observable collections and pipeable query operators in Python? And we revisit, right, observable and observers and things like that when we just touch on pattern last week. But in the prior weeks, we had talked about reactive, which is RxPy. And we did a lab that has the exercise where we use reactive. And then for 30, how can you create observables using RxPy? And we would use the method from iterable from RxPy observable. So when we import in, we would do an import Rx, or we can say from Rx import observable. And then we would be able to implement the method from iterable. Any question? Okay. 31, fill in the blank. The blank is a mode of operation where a task is executed simultaneously in multiple processors in the same computer to reduce the overall processing time. And this is parallel processing. And so in parallel processing, we were able to use virtual machine and assign multiple processor, in that each core is going to handle a process. For 32, true or false. In Python, the async IO module is used to run independent parallel processes by using subprocesses instead of threads. And no, false. Multiprocessing module is used to run independent parallel processes. So you would import multiprocessing, not async IO. So false for 32. For 33, we're given a program, which method in the program blocks the execution of the main process until the call process is terminated. So when you take a look at this program, and this is one of the example program that we use in the assignment, and it's also in the notes. And so when we work with multiprocessing, we talked about the start, the join method, and the run method, and so on. Okay. And so the join method is what blocks the execution of the main until the call process is terminated. And later on, we worked with how we would use this for a pool of processes, where we would use a for loop to start and then a for loop to join, right? Any question? Okay, so for 34, you're given a program. We want to describe the program procedures and the wait, how the wait is implemented. I should put, sorry, I missed that. How the wait is implemented in the program. So we use multiprocessing module, we import process, and we did the benchmark. So we time this particular program. We have a function called show name. It's going to print the first name. It's going to wait 2 seconds. So it uses a sleep. Okay. And that comes from the time module. So we have a pause there. And then it's going to print last name. But wait, right? In the main function, we simply define our P as an object. It's a process object, and we're going to target the function show name. We're going to start and join it. And in the main, we first going to print starting main. So it's going to print this first, then it's going to print first name, wait 2 seconds, then it's going to print last name, and then it's going to print finish main. So we define show name function, which prints first name at the start of the main. Then it's going to wait 2 seconds using sleep method. And we pass the 2 seconds in the parameter there. Then we're going to print the last name at the end of the main process, which is a child process. Okay. So real quick, that's 34. This is the exercise that we did. Oh, I revised it. So here we go. Yeah. So you have starting main, print first name, wait 2 seconds, print last name, and then finish main. All right. So here in this section, we're going to touch on features. So for 35, it says, when using executor interface in concurrent programming, what is used to extract results from future instances? And we would use concurrent future wait and concurrent future as completed functions. And then we also would implement futures dot result. So the result method. And for 36, in parallel programming, what method is used to prevent multiple processes from executing the protected section of the code at the same time? And I think we revisited this. We talked about it in, I believe unit 8. Then we came back in the later unit and we touched on lock. And so lock method would then be used to protect, right, the location and when you create multi-processes, we should allocate, we would use distributed memory for our program versus when we use threading, then we would be able to share memory. So lock method for 36. 37 touches on Amdahl's law. And it asks you, in Amdahl's law, what is used to measure the benefit of executing a computation in parallel? And that is known as speed up. For 38, what does a program's efficiency, speed up divided by the number of parallel processor calculation provide? And this provide you with the information of how well the parallel processing resources are being utilized. So you would take speed up divided by the number of parallel processors. And like the assignment, we did a practice on this. There's some slight change in the value. For 39, if a computer program is 80% parallelized using a 6-core processor, use Amdahl's law to determine the estimate speed up of the program. So your B is going to be 1 minus 80%, which is 20% or 0.2. So 0.2 would then be the sequential part of the program, as it would be 80% parallelized. So using Amdahl's law equation, we would take 1 divided by 0.2 plus 1 minus 0.2 divided by 6. So that will be 0.8 divided by 6 plus 0.2. And then we want to invert that. So that will be approximately 3. So as you can see, if we're using 8-core, it will be like 3.33 approximately. And if we're using 6-core, it will be exactly at 3. So assigning 2 additional core to that make a slight difference. I think from system to system, there will be some, we would see some difference there, but from user to system, the user probably can't really distinguish the difference between a 3 and the 3.33. So you do have a slight speed up when you add 2 more cores. Any questions? Okay. For 40, true or false, a program that is 95% parallelized can have up to 2048 cores to achieve up to approximately speed up of 20. More cores will make the program faster up to 100,000 cores. That will be false. The program will be the same or even slower because it does plateau and actually drop, right? As we cannot move completely away from sequential implementation in the program. There got to be some percentage of sequential. Then for 41, true or false, increasing the number of processor with the fixed problem size per processor leverages weak scaling to accomplish more work in the same amount of time. That will be true. And then for 42, what is the trade-off in achieving the best possible speed up in parallelization? And when we increase the number of processors, right, that will be versus the increase in how long parallelism. So we can use more core, but it also increased in the lengthy parallelism. Fill in the blank. The blank is a technique that allows CPU to switch between different software running on different threads, and this is known as time slicing. Now we're going to enter threading. So it looks like, right, it's able to run multiple threads at the same time, but it's simply switch between the threads. And it is very minute where the user can't really distinguish it. For 44, using threading module, what function returns a list of all concurrently active thread objects in the program? And that will be threading, or the enumerate method in threading module. And we can use this method to check, right, our threading objects. If you implement threading for your project. For 45, using threading module, which method returns the name of the calling thread? And that is get name. .46, true or false? The primary goal of thread synchronization is to avoid any potential data discrepancy when multiple threads access their shared resources, and that's true. And later on, we went into some of the issues when, right, data is being updated in the shared location. And how to be able to apply solution for those type of issues. So for 46, that's true. For 47, what type of data container represents an abstract data structure that is a collection of different elements maintained in specific order? And that will be a queue. And using data structure, such as a queue, right, allow you to be able to set up your thread pool efficiently. Then 48, the blank is a data extraction method that automatically makes requests to web pages and downloads specific information. And this is when we learn about HTTP requests, so web scraping. Then for 49, using HTTP requests, what method makes a request for a specific data from the server to retrieve data and has no other effect on the server and its databases? That will be GET. And so when you open your browser and access the URL, that's what's happening in the back, right? GET. And so make sure we know the HTTP request methods. And 50, which HTTP status code is received when a client sent a bad request? And that will be 400, right? So if we were able to get some kind of response, that will be 200. If it initialized the request, that will be 100. So, and this one's easy because when you type in a bad URL, you get a 404. So the 400s are usually for bad requests. "51. What type of Kotlin deadlock conditions consist of at least one resource in non-shareable state and held by an individual process thread that cannot be accessed by others?" That will be mutual exclusion. And so when we talked about deadlock conditions, then we went into race conditions, right? So in this case, that will be that it's going to keep waiting for the resource and it will never be able to execute for all the other functions or methods that's waiting. For 52, true or false? Deadlock is, sorry, all this wrong. Deadlock is a situation where a request for an exclusion lock is denied repeatedly as many overlapping shared locks keep on interfering with each other, and that's false. Live lock is the situation where request of an exclusive lock is denied repeatedly as many overlapping shared locks keep on interfering with each other. So live lock, not deadlock. For 53, true or false? Starvation can be resolved using algorithm scheduling technique, using queues to store and update or increase threads in waiting and shared resources. And that's true. So we can fix the starvation issue by implementing scheduling. And that will be it will be stored in queues. And we looked at some example on this. So true for 53. "54. In concurrent programming, what type of problems occurs during which output is determinate and dependent on the schedule algorithm and order of tasks to be executed?" And that will be race conditions. And then the last part is on design patterns, which is unit 13. for 55, fill in the blank. The blank are reusable program solutions to be applied, I should say. To be applied on various contexts and have proved to produce expected results, and that will be your design patterns. And we talked about different type of design patterns. One of them is behavior pattern, which is for 56. What type of patterns consist of objects that handle types of actions within the program, which encapsulate processes such as interpreting language, fulfilling a request, moving through sequences, and implementing an algorithm. And so that will be behavior pattern. And the other type of design pattern is the creational pattern, which is part of 57. What type of creational pattern includes a group of factory methods where each method is responsible for generating different kind of object, and that will be abstract factory. And just a few more and we'll be done. And another type of pattern is your builder pattern. 58. In a builder pattern, what component controls the building process using the builder instance? And that's your director. So the director controls the building process using the builder instance. And 59, what type of pattern is used to copy the object structure to produce a new object, creating a deep copy of the object? And that's your prototype pattern. And lastly, 60. What type of pattern wraps the original class and provides additional functionality, keeping the class method signature intact? And that's your decorator pattern. Okay. So this is going to be our last Zoom session for this class. If you want to, for most of you who needs to finish the certificate, you can take the 30C in spring. I am teaching it at the same time via Zoom, so you can keep the same schedule. It will be Monday, Wednesday at 5 to 7. And but if you miss a class or two, we are looking to reoffer those possibly in the later semester. Right now, they actually wanted me to drop one of the class from my 5 classes because I'm overloaded. So we will see how my schedule is gonna pan out. But yeah, so as I don't have that many people who can teach some of the Python classes, so I will be teaching the Python in cybersecurity, where we would use script for different purposes in risk assessment and cybersecurity. It'll be fun. Okay. All right. so we don't need to meet on Wednesday. I am going to be on campus tomorrow for my CIS30E class. And then I will be on campus on Wednesday morning for those students that are making up the labs in some of my classes in person. But if you have questions or concern, and if you like to meet on Zoom, I'm open to do that while I'm on campus for my office hours. But because Friday is a holiday along with Thursday, I will not have office hours this week on Friday evening. Okay. But you can shoot an email if you want to schedule something before the holidays or after. Any question as far as final exam? When is the final posted? I will post the final exam on the 13th, and you will have, for this class, you have 13th, 14th, and 15th to work on the final. Okay. It is time, and it will have lockdown browser. And then for the other class, you will have until Thursday, which is the 16th. So the last day that we close out on all our classes for the weekday is the 16th of December. So I will post the final on the 13th.
Professor, so 30C will most likely be offered in the spring?
It is, so unless they don't, well, let me stop recording.